Okay, Math 20-1, we're in topic 3.2. We're looking at quadratic functions in standard form. That is a form where f of x is equal to ax squared plus bx plus c. But first of all, let's just do a little bit of review. We know that y equals a times x minus p squared plus q, or f of x equals a times x minus p squared plus q, is a quadratic function in vertex form. The points P and Q are going to be the vertex. We can also tell that Q is going to be the maximum point on our graph if A is greater than 0, and Q is going to be the minimum point on our graph if A is greater than 0. Sorry, the other one was less than 0. Nice start. X equals P is the equation of the axis of symmetry. That's a line that goes right through the vertex. It'll be symmetrical on both sides. Now, the A value controls how wide or how narrow the parabola is going to be. A also controls the direction of the opening, whether it opens up if A is positive, or opens down if A is negative. Now, f of x equals ax squared plus bx plus c is our quadratic equation, or quadratic function in standard form. Same equation, but a different form. Now this time, a and b and c are still real numbers. A can't be 0. Again, a will determine the shape of the graph and whether it opens up or down. Of course, if a is positive, it opens up, and negative a, it opens down. B is just going to influence the position of the graph on our plane, and C is always going to be the y-intercept of the graph. The x-coordinate of the vertex this time is going to be found if I go and take the negative of B and divide it by 2 times A. And if I wanted to find the vertex using this method, I could take this value and plug it into my equation, and that would tell me what y was. In example 1, we're going to look at the different characteristics of quadratic functions in standard form. For each of the following functions, identify the following. The direction of the opening. Well, this opens upwards. The second one opens upwards. The third graph opens downwards. And our last graph, again, opens upwards. The coordinates of the vertex, well, that you can read off the graph. In the first one, it's right at the origin, 0, 0. The second one is when x is 1 and y is negative 1. The third one is when x is 1 and y is 9. And the fourth one, when x is 3 and y appears to be about 7 or 8 or 7.5, about. This third graph, is there a maximum or a minimum? Well, this has a minimum at 0. The next one has a minimum at y is equal to negative 1. It doesn't go any lower than that. The third one is going to have a maximum this time at y is equal to 9. Can't get any higher than that. This one, last one's going to have a minimum at 7.5. Next, the equation of the axis of symmetry. In the first one, you can draw a line right through the vertex, straight up and down, so that would be x equals 0. The next one is going to be at x is equal to 1. Next one is also x equals 1. And the last one is going to be at x equals 3. Next, we have the x and y intercepts. Well, the first one just touches the x-axis at 0, 0. So both my x-intercepts and my y-intercepts are going to be at 0. The next one now, notice that there's going to be x-intercepts at 0 and at 2. The y-intercept is also at 0. That's where it cuts across the y-axis. In the next one, we have an x-intercepts at -2 and +4, and a y-intercept at +8. Last one has no x-intercepts, and it has a y-intercept at +25. Lastly is domain and range. For all four of these parabolas, the domain is x can be any real number. So we're going to say it's a set of all x such that x can belong to any real number. X is any real number. X is any real number, x any real number, any real number. For the range now, y is going to be restricted because y in the first graph of A never gets less than 0. So we'll have to say that the range is the set of all y such that y is got to be greater than or equal to 0, comma, and y is any real number greater than or equal to 0. B, this time, y has to be greater than or equal to -1. In the third graph, y is now going to be less than or equal to +9. And in the last graph, y has to be greater than or equal to 7.5. In example 2, let's analyze a quadratic function. Frog sitting on a rock jumps into a pond. The height h in centimeters of the frog above the surface of the water is a function of time, t, in seconds, since he jumped can be modeled by the function given. Where appropriate, answer the following questions to the nearest tenth. Graph the function. So what we're going to do is we're going to graph this on our calculators, we're going to play with the windows, and we're going to see what fits, and then we're going to reproduce it on paper. And if you did that, you should find that you need to make my x-axis go from tenths or decimals. I'm going to make my x-axis go in 1/10, 2/10, 3/10, 4/10, 5/10. I could have used decimals or fractions. The height now is going to go 0 to 25 to 50. And if you plug these values in, some of these values into your calculator, when x is, you can trace along your graph, you can start plotting some points. And then from there you can draw the curve. Then we have A, graph the function. There we go, see the graph. B, what is the y-intercept and what does this represent? Well, B is the point, the y-intercept would be the point where the frog is jumping from, at the top of a rock 25 centimeters above the pond. At time 0, he's about to jump. C, what maximum height does the frog reach? You're going to have to use your second function, trace or calc, and then 5 for intersect, or I'm sorry, for 4 for max, and you're going to have to set your left boundary and your right boundary, and then press enter to find the maximum between your left and right boundaries. That should tell you that you have a maximum at 36.48 centimeters, and that'll be 0.1531 seconds after he jumps. The y-coordinate will be 36.48, and the x-coordinate will be 0.15. D. When does the frog hit the surface of the water? He's going to hit the water 0.4259 seconds after he jumps. You can find this by setting a second equation of y2 equals 0, and then again you can use your intersect feature on your calculator. The domain is going to be from 0 to 0.4259 because that's as long as he's in the air. So x is going to be less than or equal to 0.43 to the nearest hundredth, but greater than or equal to 0 and any real number in that range. The range is going to be, which is the set of the y values, again it's going to start at 0 to the maximum height So it's got to be less than or equal to 36.5, but greater than or equal to, of course, 0. And y is any real number in that range. Lastly, how high is the frog 0.25 seconds after he jumps? This time you can press trace 0.25 and it'll tell you that it's going to be 31.88 centimeters high. Lastly, write a quadratic function to model a situation. A rancher has 100 meters of fencing available to build a rectangular corral. A. Come up with a quadratic function in standard form to represent the area of the corral. Well, we know that if we have 100 meters of fencing, that's got to go around 4 sides. Let's look at 2 sides. 2 sides are going to give us what we need. Because we don't know how long one side is, we'll call it x, but the other side has got to be the rest that's going to add up to 50. So if one side was x, the other side has to be 50 minus x. Together those two would add up to 50, and that means the other 2 sides would add up to the other 50. Now that I've got a length and a width, I can come up with an equation for the area, because the area is length times width. So we can say that area has got to be length times width, or x times 50 minus x. Now when you multiply this out, you're going to get the area is equal to 50x minus x squared, or if I rewrote that in the other direction, a equals negative x squared plus 50x. That is A. Write a quadratic function in standard form. B. What are the coordinates of the vertex? Well, let's graph this. And if you play with it on your calculator until you get some settings that are going to show you what you need, you're going to see that you can plot some points and draw your curve. Now we can use the features on our calculator to find these points. What are the coordinates of the vertex? Again, I'm going to have to use the max feature, and I'm going to find when x is 25, y is 625. Maximum area is 620. What does that represent? The maximum area, 625. Sketch the graph of the function. We did. Determine the domain and the range. Well, x has got to be from 0 to 50, and y has got to be from 0 what does that say? 625. I got that backwards. Fix that. You can fix it. And E. Identify any assumptions you made. Well, just that he's going to be stopping there because that's when he hits the ground. Or that's going to be the maximum area. Your assignment for day 1 was to do page 174, 1 to 7, and day 2, page 175, 8 to 17.